Hello F-sharp and welcome back. Today we are going to talk about classes in F-sharp. I find it kind of shocking when I reflect on how far we are into this Intro to F-sharp series and we have not talked about classes at all. And what's funny is that so much of the industry spends so much time talking about classes, but we don't seem to. Now the reality is we've been utilizing classes in F-sharp for quite a while. It just hasn't been clear to us that that is what we are doing. And what I mean by that is that F-sharp records are encoded as classes in the .NET runtime. Modules are classes in the .NET runtime. Discriminated unions are classes in the CLR. But you don't see that. And the reason is because the F-sharp language is designed to be a simple and easy way to work with and transform data. Because fundamentally, F-sharp is a language about defining types, defining data, and defining transforms on that data. That's it. It's not really concerned with object hierarchies or inheritance. And in fact, I don't want to say antagonistic to inheritance, but it's severely de-emphasized. The preference is to use discriminated unions instead of multiple inheritance or those ways of composing domains. So we haven't really needed classes yet. Now, today we are going to talk about how we would define a class in F-sharp, but it's not something you need to reach for very much, and I'll discuss why at the end. But for now, let's talk about how we would define a class in F-sharp. And the way we would do that is we say type, and then we give it a class name. I'm going to go ahead and zoom in here to make it a little easier for you to see. And then we give it the parameters for the constructor for our class. In our case, we're going to say, hey, we have a name of type string, and we have a size of type float. And then what we want to do is we want to add some members to this class so that our class actually does something. Like right now, it's like, okay, the compiler's saying, okay, you're defining a thing, but I need something. You need to tell me like what is going on here. So we're going to go ahead and define some members. And those members are going to be name equals name and member size equal to size. And what we've done here is we've just defined two members which expose these values. Because right now, this class is hiding this data. It's taking it in as a parameter and then it's saving it internally, but it's private data to the instance of the class. It's not available to anything else. And so we have to expose those values using members. Now, I want to unpack what this is saying here real quick. We use the member keyword to say that this is a member of the class so that when we create an instance of it, we should be able to access this using the kind of dot-driven design, dot-driven programming. And I'll show that here in a moment. So, okay, well, I'll go ahead and create an instance, right? So now I've defined a class. I said this class's name is chicken. It takes two parameters, a name and a size. I'm going to create an instance. So C1 is equal to chicken. And then I give it the parameters for the constructor because right now this is the primary constructor for the class. And I say, okay, name is Clucky and size is equal to 10. So now I have an instance of chicken and I should be able to use these members. And so if I see one dot, and I see that I have access to the name member and the size member. Fantastic. Okay. Now, this isn't terribly exciting. What else can we do with classes? Well, one thing that we can do with classes is we can add some validation now. We're saying like, okay, well, our particular class, like we want some validation around the name input. And so what we would naturally do, the first thing that you would reach for is this. It's like, okay, well, if system.string.isNull are empty, and we want to make sure like, hey, if the name value is null or empty, we want to throw an exception saying like, hey, no, this is not valid. Say is null or empty name, then, okay, we're going to throw an invalid arg exception and say name of name and chickens must have names. Obviously, I would probably give a better description here, but the invalid arg function takes the argument name and a message that it's going to use in the exception that it throws. The name of function is just a helper function in the fsharp library. You can see it's in Microsoft fsharp core operators. And what it does is it's able to look at whatever this parameter is, and it will give you the name of that parameter. So name of is going to give us name as a string to say like, hey, this is the name of the parameter. This is really nice so that we can refactor here and say like, okay, now we're going to say this is chicken name. Well, ideally the refactor would have caught that, but name of would have then changed its result to chicken name. But you probably don't need to worry about that yet. I'm just wanting to explain to you what is going on. And then this is the message that's going to be included in the exception that is thrown. Okay, but we have a problem here. It says unexpected keyword if in this type definition. So we have something interesting going on here. This is the constructor, and the constructor is expecting let bindings and another thing which we haven't discussed yet, which is do blocks. And what is that? So if I put do here, we now see like, oh, this is happy. So a do is a feature of fsharp which says like, hey, I'm going to do some imperative stuff now and don't worry about it. That's how I think about it. There's probably a more exact definition, but when we are in the class constructor and we want to do some imperative stuff, we use a do block to say like, hey, I'm going to do some work. It's going to return type unit. It's not actually going to return any values, but I still want to run this logic. And so we put our validation logic in here. And so, okay, now if we say like, hey, let's see, 2 equal, okay, so this is null or empty. So this exception should be thrown on a null or empty. So I'm going to say, hey, chicken, give it an empty string, get a value of 10. I'm going to go, well, let me run it with working syntax first. So this first case where I create a chicken with the name of Clucky and have a size of 10, it works successfully. When I try to give it an empty string, it throws an exception saying, hey, chickens must have names. And then it says like, hey, the parameter that is wrong here is name. And this is coming from that name of function. So I've done some validation now. So this is one of the things that's valuable about classes. Like, why would you reach for a class instead of some other construct in fsharp? It all comes down to classes give you more tools for controlling and manipulating data than the simple types of records and discriminated unions. And you know you need a class when you outgrow the capabilities of records or discriminated unions. It's hard to provide a more exact definition of like when you need to switch to classes, but that's kind of the general guidelines. You'll know you're there when trying to use records or discriminated unions is causing it to be exceptionally difficult, or you're wanting to hide state all the time, or you're wanting to wrap some type of mutable state. Okay, those are candidates for moving up to a class in terms of the amount of complexity that you're willing to take on. So I'm going to come back here to these member declarations. One of the things here is this underscore. Like, what is this? So what this is this is where you would put a self-identifier. So often you would expect to use something like this, like the this keyword. Fsharp does not actually have a this keyword for self-referencing. So you're like, hey, I have an instance of an object and I want it to reference members of itself. this keyword in C# is what you would use. Now, F# doesn't have it. You can say whatever it is that you want. So this could be X, and X would be referring to the instance of chicken that you're working with. Or you could say chicken, and chicken would now be the way you would refer to that instance of a chicken. And so I often use just the first letter of the name of the class. If the class has a more sophisticated name like alt chicken, that seems kind of silly, I know, but like, hey, okay, in that instance, I might use AC. Other people will say like, hey, just use this. I see X used quite frequently. It's kind of up to you. I'm not aware of a hard and fast rule for how we do it. So my recommendation is follow the idioms of the code base that you are working in. When I use the underscore, though, that is me saying, like, I don't care. I don't care about the self-reference in this context. So, and most of the time, this is true. I don't need a self-reference. And so I just use an underscore here. So that is an example. So that is how I can define the members. I can add members to this. Now, something else that you can do with classes is you can provide alternative constructors. And the way you would do that is you would say, hey, new. And let's say I want a constructor for chicken that doesn't actually take any parameters at all. It's like, hey, just give me some default values. And so what I will say is like, okay, what I'm going to do is I'm going to say default chicken as its silly name. And for some reason, all of our chickens are size 10. So what is this doing? I am providing another constructor that can be used for creating instances of chicken. And the way I do that is I call the default constructor, which is what this is, with, oh man, is that the right way to say that? I'm not sure if that's quite the right way to say that. Is it the base constructor? I'm checking here real quick. Primary. Okay, this is the primary constructor. And it is the constructor that is kind of like all other constructors need to end up calling that constructor at the end of the day. And so I'm providing an alternate constructor. It calls the primary constructor, which is this one. It's this top level one. And I'm giving it some default values. I could also say, and let's go ahead and use that. Let's go ahead and say like, okay, let C3 equal chicken. And I'm not going to, oh, C3, come on. C3. Go ahead and run all of that. Okay, this is throwing an exception. Come on. So now C3, and yep, I have C3, and I want it to go ahead and print some things out for me. Great. So I have C3. It is our default chicken. We say it has a name of default chicken and a size of 10, and because it used this constructor. Now I can provide an alternative where I say like, hey, you know what? Give me the name. And I'm going to call the primary constructor with the name that you gave me, but I'm going to provide a default value for the size. So now what I can do is let C4 equal chicken, and I'm going to give it a bok as its name. Go ahead and run all of that. And now I have C4. It has used this alternative constructor. And if I go ahead and print that out, I should say, yep, this has a name of bok and it has this size of 1 because that is the default size when I use this constructor. So this is fantastic when you're wanting to provide an API for your users that has different constructors for different scenarios. Now, another thing that we can do with classes is we can define let bindings in the constructor as well. And those are functions that we can use in our members. So let's create a silly thing where we could say, okay, let can create a grow function, and I'm going to say, hey, new size, and it's going to be a float. And what this will do is this will return a new chicken. It'll have the same name as this instance of chicken that we are using, but it's going to take on a new size. Now, this is a let binding. It is not available to us when we have an instance of chicken. It is hidden, so it's a private. And if we want to expose that functionality, what we can do is we can say, hey, we're going to define a member here, grow, and it's going to take a new size. That is a float. And it is going to call this let binding. It is going to call this function that we have defined here. And so grow and new size. And now we have a method on our class that we can call. And this is going to give us a new instance of chicken. So we're going to call this C1-2. And so C1 grow, and we can give it a new size if we want to. So if we go ahead and run this, and then we run this, we get C12 and say, hey, it used the name from the previous instance, but it used this new size that we gave it in this member. And so this is an example of a member that is available to instances of chicken, but it is then calling functionality that we have defined up here. Now, I find this very useful when I want to have some sophisticated logic. And instead of having giant members, I often have these let bindings, these functions defined up here that I can then reuse across multiple members. And so if I have several different versions of the grow method, like grow and big grow, or I don't know, just think of it is entirely possible that you have multiple methods that end up using the same type of functionality. What you can do is you can take that functionality and put that in a let binding that you can then reuse across the different members. Now, something to think about. Classes in F# are allocated on the heap. But you can do something like this. And this is going to complain. And the reason it's going to complain is because now when you want to say like, hey, this is a struct, certain features are going to be now disallowed because of the fact that like, hey, this thing is going to be potentially allocated on the stack. The behavior needs to be differently there. So I know previously I have shown being able to define a struct in this way. This is where the additional features of classes come in. It allows you to do this additional validation. It allows you to define and use things that you wouldn't be available otherwise. Now you may be asking, okay, why have a class when you could just have a record that is like this? That is a great question, because most of the time you would end up just defining a record. And at the end of the day, these are both classes. Alt chicken is an F# record that compiles down to a class. It's allocated on the heap. Chicken is a proper, air quotes, class. It is also allocated on the heap. Why would I use one over the other? And the question really comes down to, what API surface are you wanting to provide to the user? I typically only reach for classes when I'm defining a new collection type. And I'm planning on creating a series where I take you through the exercise of, hey, there's this new collection type, it's slice set, that I need and has some very unique functionality, but I don't want to expose its internals, and I want to provide a very specific API surface for the user to use it. That complexity naturally suggests like, hey, we should really be using a class in this, because there are internals that we don't want exposed, and we only want to expose certain features of the object that we are working with. F# records are incredibly useful because they are very simple. They're a great way to model our domain and model data and to define functions which transform them. But everything's exposed by default. You get some nice default constructors here. Records are a great way to just have a bag of data. But if you want to start adding functionality to it, if you want to have a very specific API, and if you're wanting to hide pieces of data that are contained in the record, that is a sign that maybe you should be reaching for a class instead of a record. So again, most of the time I use records. I very rarely need to reach for a class in F#. It is only when I need to hide those internals and provide a very specific API experience for clients that I end up reaching for classes. And the most common scenario is implementing new data structures. That is by far the most common scenario. They're like, oh, yep, this is going to be a class. So it's there. I want you exposed to it. It's important to be aware of it as a feature in the F# language, but most of the time you are not going to need it until you get to the point where you're a library author and you're writing libraries for other software developers to use. At that point, you're like, yeah, you might be working in classes a lot in that case, but you have now moved to a very different part of the F# developer ecosystem at that point. Beginning F# developers, people early in their career, and people who are doing business logic, they're typically going to be very well provided for using just F# records and discriminated unions. Like I said, I am going to have another series where I go really deep into F# classes and how to use them for creating new data structures, but that's going to be much longer. And so there are many more features of F# classes that I'm not talking about here, and as very purposeful because you probably don't need them yet. So I hope that was helpful. I really appreciate you spending some time with me. I know that this has been a really long intro series, and we're hopefully getting near the end here pretty soon. So until next time, thank you very much, and you have a great day. Bye-bye.